So where do we start with Newton? It's really difficult to appreciate just how brilliant the man was until you've looked at where he was, where the world was before he did his work, and where the world was after he did his work. Among other things, he had to invent calculus in order to do what he did, so he invented a whole new mathematics to handle his physical principles. And he wrote it all down in Latin because that was the language of the day, in Philosophiae Naturalis Principia Mathematica, which, if you want it in English, you read backwards, Mathematical Principles of Natural Philosophy. Natural philosophy is just what we used to call physics. You know, the philosophy of how does the world work? How does nature work? So one of the things that Newton really got to is a better idea of what a force is. And a force has both a magnitude and a direction, so it's a vector, and you have to keep track of its components, right? And in Newton's three laws that we think of are sort of like a starting point for everything he did, but here we go. The first law is inertia. An object at rest will stay at rest unless acted on by an outside force, right? Now that outside force in this case might be a biscuit or something, but you know, that's that. When you start thinking in terms of Newton, you have to think in terms of what system are you dealing with, because this is very important. You have to have some boundary, and so in this one, you know, there are several different boundaries you could draw, but in a lot of problems you have to narrow it down to, okay, what is the system of interest that I'm talking about? And so in both of these, what we're after is what's happening with the kid in the wagon. And so the two people pushing it in the top one and the one person pushing it in the bottom are both outside the system, so they're outside forces. All right? Better view of this. The people pushing on him are outside forces. So, what did Newton say about force? Force is mass times acceleration, or really, this is where he defined acceleration. Acceleration of a mass is the net force on it divided by its mass, right? So F equals ma is Newton's big equation that everyone, you're going to have to remember this one. You're going to know this one before it's all over. F equals ma. Gravity is such a force. So the acceleration of gravity times a mass is your weight. And it has a direction straight down towards the center of the earth. We don't normally think of weight having a direction, but it does. It's a force. It has a direction. We normally think of it in terms of the scalar, pardon me, right? Because we step on a scale and it just gives us a number because we know it's straight down. The last third law of motion is every action has an equal and opposite reaction. So whenever you look at a system, so in this one it's been illustrated with two different systems. You take the cart as a system. Then the person pushing on the cart is being pushed on by the cart just as hard as the cart's pushing on them, right? I mean, this is symmetric. The cart's pushing on the person as hard as the person's pushing on the cart. The person's foot is pushing on the floor and the floor is pushing on the foot. Friction is pushing on the cart and the cart is pushing on the floor. All of these things, equal and opposite forces, right? Equal and opposite forces by Newton's third law. And you're like, but that doesn't make sense because I know things are moving. Well, yes, they are. But if this, right, here is an example of equal and opposite force. The force of gravity, force of my hand, they have to cancel out and be, otherwise, you know, things are not quite kosher, right? So this is an example of it. The normal force is one we'll talk about all the time. The normal force is simply the force from one object onto a surface, right? Normal force is force onto a surface. So that's straightforward, easy to take a look at. If we're at an angle, we start having to work out, what component is actually into the surface, because part of it's down the surface and part of it's into the surface. Other types of force, tension. So ropes are great for transmitting force, and pulleys are great for transmitting force, because you take something up and over a pulley, and all it does is change the direction of force for you. But if you look at the details of what's happening with the pulley, there's a lot of force on the pulley.